Hi everyone, welcome to our presentation on the design of power drill. We are Group 22. My teammates are Dave, Joe, Siyuan, and Yining, and my name is Shuangxuan. So power drill is a device that can be used to create holes on a variety of materials, for example, metals and woods. Also, it can be used to install or remove fasteners with a drill bit installed to it. It provides bidirectional torque with a motor inside, as well as a direction switch around the body. For the model we use, it also has some safety features that prevents overheating. A CAD of the model we use is going to be shown in later pages. So this page shows the primary and the secondary customers of the power drill. The primary customers are from professional production environment, for example, factory technicians, construction workers, etc. And the secondary customers are from educational environment, for example, high school or college students and school lab teachers.
What we have here is the fast diagram of the power drill. The main function is to drill holes, and the basic functions we have are to secure tools and to rotate tools. The sub-functions we have for the secure tool is to maintain position and apply force. For the rotate tools, we have sub-functions of generating torque and maintaining torque. We also included the assured dependability, assured convenience, enhanced product, and please senses. What we have here are two feasible assembly sequences, the first sequence on the left and the second sequence on the right. For the first sequence, we start off with the left housing, followed by the assembly of the components, and then closing it with the right housing, and then attaching the power supply at the end. For the second sequence, we start off with the assembly of components first, and then closing it with the housing, and then attaching the power supply at the end. We created a table of assembly sequence analysis to compare the two feasible assembly sequences, and then scoring them in each criterion. The second sequence have the higher score than the first one because of the ease of locating parts, with the left housing holding the other components, making it easier to assemble.
This page shows the function component mapping matrix. For functions such as generate torque and maintain torque, they mainly involve the motor, gearbox, as well as the trigger. Some other user experience related functions such as preventing injury and minimizing noise and vibration are closely related to the design of power drill housing. Besides that, the drill bit holder provides the interchangeable bit attachment.
Here is our bill of material. There are totally 11 types of parts including fasteners. We list the material and manufacturing process for these parts, and for parts include drill motor, chuck planetary, gear sight, trigger switch unit, temperature sensor, and battery kit. It is decided to purchase them online because of the parts property, functions, and manufacturing difficulties. For analyzing the total cost, we consider the material cost, processing cost, assembly cost, and tooling cost. Most of the parts are made by either ABS plastics or aluminum alloy, and the others are all in metal. By using 2 million batch size, we use the website custompartnight.com to estimate the material cost, processing cost, and tooling cost. We assume all parts are manually assembled because of the complexity and part size, and the total cost for one power drill is $66.85, which is 3 times lower than the market price.
We decompose the CAD into following 10 subsystems. Note that the trigger, trunk, gearbox, power supply, and motors, they are complicated assemblies themselves. To make the product doable for us, we treat them as pre-assembled parts. Our primary design may be used under tough environment with high cutting load and therefore need a stronger trunk and gearbox. They are also equipped with battery as power supply so that they can be used where electricities are not accessible. The secondary products are for a nice screw environment. The low cutting force and easy access to electricity make light-weighted transmission and power supply possible. Within the product family, the housing, the motor, trigger, sensor, they are the shared platform, which is shown as solid part here. Different product only differs in transmission and power supply modular, and the interface involves screw, pinion, and adapter.
From the fast diagram, we categorize its functions by customer groups. The functions of maintain position, apply force, and store energy are required in different ways for its customer groups. For professional use, they need to maintain position more reliably, need to apply more force to secure drill bits better, and need to store energy to run the power drill more conveniently. whereas for student use, those functions aren't as important. The rest of the functions listed are the same functions for both customer groups. Here is our component commonality table. So the chuck and gearbox and power supply will be different for the primary and secondary customer group, and the rest of the components listed under platforms column are shared for both customer groups. Here is our original assembly sequence diagram obtained based on the better assembly sequence for the primary product variant. Here, it can be observed that there are two variations of chuck and gearbox that are assembled at the beginning of the sequence. Power supply also has two variations, however, it will be assembled at the end of the assembly sequence. Here is our delayed differentiation assembly sequence. The chuck and gearbox assembly was moved to the end of the assembly sequence. From the beginning until near the end, there is only one family, and the assembly will be split off into two families near the end of the assembly sequence.